Okay, so in the last video we set up the axonometric plane and isometric projection using the axonometric planes. Okay, so if you haven't seen that, look at the video before you continue on this. So in our question we have a scale of 1 is to 10. Okay, so scale of 1 is to 10, it means that anything you have you divide by 10. Okay, so here it says it's in meters, so 0.8 meters we know is 800 millimeters. So dividing that by 10, we get 80 millimeters. Okay, so that's going to be 80, that's going to be 10, that's going to be 80, that's going to be 15, and that's going to be 30. So we have all our sizes there now. Okay, so the next thing we need to do is we have got a polygon. Okay, we've got a polygon, and we know that it is a hexagon. Because if it's a hexagon, it has 6 sides, okay, and we know that it will fit inside a circle. So we know that this is going to fit somewhere inside our axonometric plane. Okay, so we need to draw the plan, draw the elevation. Okay, so we have our plan view set up here. So we need to draw a plan here somewhere, and we need to draw our elevation here. We need to find our points in 2 views, then to locate them in the 3rd view to make it into a 3D object. Okay, so the first thing we're going to do is look at the hexagon. So we know a hexagon fits into a circle, and we know if we drew a circle, it would go around. We'll touch the corners there. So that would be our diameter. So we have our diameter and we have our center point. So somewhere on the page, so you should have room up the top. So I'm going to just draw it out on the top. We're going to draw a portion of our hexagon, so we can continue taking measurements from that throughout the drawing. So first thing I'm going to do is I'm just going to draw a line, random line. We can see that it's 80 is the diameter. So on that line I'm going to measure 80. So from there is 80, so the center point is 40. So we do the center point. So I know if I swing a circle using that center point, the radius of 40, radius of 40. So using your compass, just swing a circle with the radius of 40. Okay, that's not too bad. It's easy enough, I think, for everyone. So we can see here that semicircle represents this semicircle here. Okay, so we have a hexagon has 6 sides, and we know a circle has 360 degrees. So we divide it by 6 to get the angle, the internal angle for each side. So 6 into 360 goes 60 degrees. So we know it's 60 degrees. So from this point here, we're going to use our 60 degree set square to make it easier for us. From that point, we're going to bring it up. We know then that is going to be that edge there. So I'll label it just to help people. I'll just fold this. Okay, so that edge here is A, we call that A, so that point there is A. So this point here now is going to be B, so that point there is going to be B. So we need to find C and D, and we've half the hexagon drawn then, and if half the hexagon is drawn, it's the same on the other side, because it's symmetrical. So we're going to just bring that line across here, where it hits that point, we're going to bring down. So we can double check that, because that should be also be 60 degrees as well. Yes, so that's 60 degrees here, and that's going to be 60 degrees there. Okay, we have A, B, C, and D now. Okay, we also have these distances. So 1, 2, 3, and 4. So we have all them distances. So I'm going to draw them distances in. Okay, so that distance here, we'll call that D1. and this distance in the middle then, we call that D2, and we call that then distance here D3. Okay, so we've all them distances. We know our plan using them distances here, that we have half the plan drawn apart from the hidden detail. So we can use that distance now to put in our plan. So we know then from this edge to the center is going to be how to start off our drawing. Because this edge BC is going to be touching the vertical plane. Okay, so just going to zoom out. Now, hopefully everyone will have no problem seeing this. So this distance we'll just call W because it's half the width, so W1. Okay, we know that edge, if we stuck our plan up against the horizontal plane, that edge here, BC, that edge BC, would touch the vertical plane. So that's how we start the question. So we have the distance there. We're going to use our compass to take that distance. Okay, so just take it that distance there. So we can step off that distance in plan. So that distance from there to there is W1. Okay, and we swing it and give us the distance there. So we know our center point of our hexagon is located along that, and it has to be parallel to the vertical plane. So draw a line out. That's our first distance. Okay. I'll just draw it a little bit heavier so everyone can see it. Okay, so once that's located there, we can start putting in our distance 1, distance 2 and distance 3. So using our compass again, okay, it's the easiest way of taking a measurement in case it's in the middle of half a mil or anything like that. Use your compass. We're going to take distance 3 from there to there. So distance 3 from there to there, and we step it off. That's going to be distance 3. So I'm just going to call it distance 3 from there to there. So hopefully everyone can follow this. Then we're going to take distance 2. Take distance 2. And then we're going to take distance 1. So distance 1 and 3 should be the same. Okay, so we have distance 1, 2 and 3. Distance 3. So we get our set squares now, and all them are going to be parallel to the axis here. So draw it out lightly. Draw it out lightly, then in plan here. Now, so we know, I'm missing one there. So we're going to take, just going to move that slightly. Yeah. We're going to take the portion of our hexagon here that we have. So we have B, A, so that's A, that's going to be B, that's going to be C, and that's going to be D. So we're going to join them all back together. So we heavy them in because they're staying. Okay, so we'll just draw them in black because they're going to be solid lines, so everybody can see them. So that's going to be A, B, C, and D. Okay, so we know that a hexagon is symmetrical. So if we brought our line out, we know our other points. So if we continue this out, I'll just sketch it out. If we bring our line down and bring that out at 60 degrees, that's going to give us our next point. If we bring this line down and come out at 60 degrees, and that's going to give us our next point. So we can call that E, and F. So on here we know E is on this line somewhere, and F is on that line somewhere. So all we need to do to finish it off, we have a few ways of doing it. The easiest way would be take the distance from here to here and just step it across. Okay, or take the distance of the edge, because all the edges are the same length, and step it across here. Take the distance off that edge and step it off here. So that would give us E, and that would give us F. We join them back together, E and F. So there's E. There's F. And then F goes back to A. Okay, so we nearly have it finished. We have the outside hexagon done. So we can see here, if we come in 10 mil parallel to all the edges, will give us the hidden detail of the pillar, and that all the capons here are equilateral triangles, so we need to join them back together once we have the center point. So to find the center point, we had it here, we have our center line. If we just bisect that, it will give us our center point. So we have our line here, so I'm just going to bisect that now to give us our center point. So that's our center point. So all our edges are going to go back to the center point to find our apex. You can see that there? It all goes back to our apex. So it all goes back here to our apex. So I'm going to join it back together. I'm going to use the black pen so everyone can see it as well. Okay, oh, making a mess of that now. To be a straight line. Okay, so next thing we need to do then is we have parallel line in 10 mil all the way around. So all we need to do is any line perpendicular to it, measure in 10 mil, mark it, then using your sliding set squares again, we're just going to put in all the hidden detail. So all the pillars, you can see the pillar on the inside is parallel all the way around. So we set up parallel there, put in our hidden detail. Where that touches there, we'll give you the distance for the next one. So we get that parallel. Next one then is going to be parallel also. All the way around. You'll know if you go wrong because your lines won't line up and it'll have a different distance all around. Just take your time. And the very last one. Okay, so that's your plan finished. Your axonometric plane is set up and your plan is finished. Now we have to do our elevation and finish off our view. So I'll do the elevation in the next question, in the next video, just so people can do it step by step.